Thank you, ma'am.
So, can we start now?
Yes, ma'am, you can start now.
Okay, I'm unable to. Oh, have you given me the sharing option?
Yes, ma'am. There is an option present now. Yes, ma'am. Screen share, ma'am. Now visible.
Able to see?
Yeah, ma'am. Yeah, ma'am. Yeah, ma'am. It's visible.
Yeah. So, good morning, everybody. So, and I extend a very hearty thanks to Dr. S. Jameen Begum, from whom I received the invitation, and also to my good friend Lata Jodi. So, professor in Department of Computer Science, and I feel privileged to be a part of this FTP. Main reason is my new area of interest is human-computer interaction. And when I went through this FTP in specific of AICTE trust area, one of the trust areas, AR, VR, and the way this FTP has been organized, I was just going through I should really congratulate the person who has designed this, because it starts with the introduction, then there were use cases in business model, in mental health as well as healthcare and education and all application, gaming, all these areas has been covered. Apart from that, more than application point of view, there is a SDK, software development kit for, or the platform for AR development. Euphoria is also included. And one practical example of Google Cardboard. I think yesterday you must have had it, right? The audience. So that is also done. So a practical approach also has been given, and also platform for creating from software side. See, most of us, the audience, I think, must be from computer science and information IT department. So for them, the development kit or the software development kit and the platform for creating a handheld and digital. Hello. Hello.
Oh, yeah, ma'am. Yeah, tell me.
So it has been a whole package of AR, VR platform that we are covering in this FTP, and a very small part of it, exploring the displays in AR, VR, is what we are going to talk for, discuss. Instead of saying talk, I would like to use the word discuss for the next 1 hour. Okay, before I would start going into it, I would like a few questions from the audience, few answers from the audience. So, have anybody used Alexa? Participants? Anybody has used Alexa, Google Alexa?
No, ma'am. No, ma'am.
Okay. Has anybody used Snapchat? I think more than us knows, students would be using the Snapchat more. Okay. So the whole world of human-computer interaction has taken a different form. Earlier, the interaction with the system was mainly through our keyboard, mouse, or some extra devices like virtual keyboard, or so those were the interaction devices. But now the communication has gone to the next level when we are talking about augmented reality or virtual reality, where we are moving into a different arena of computation. So to start with, what are the takeaways from this FTP? By end of 1 hour, we would be able to tell after a brief introduction about AR and the main difference between AR, VR, I think we would have already known that. I will quickly go through the slides. We would be learning about the devices, and also we would be learning about the technologies and platforms for the AR devices, and how feeling and sensing. See, basically the virtual or the augmented reality, we are trying to get in all the 5 senses. So the feeling and sensing, also how it has been brought into this AR, VR concepts and a few applications. And I would just go through the application names. The idea of this 1 hour session is to introduce you to most of the technologies as well as the principles behind it. I know it's going to be near lunchtime, so I would like to keep it lesser, lighter side, so that you would be able to have some solid takeaways from this FTP for you to learn or investigate later. Fine. I think I've set the forum for our discussion. And now, I think we would have discussed extensively in the past 2 days about AR, VR, MR and XR. Have you heard of MR and XR?
Yes, ma'am.
Okay. So basically, when we are talking about XR, it covers all the technologies that enhance the senses. See, AR and VR, yes, we are comfortable. So extended reality is the ultimate reality we are trying to achieve, where all the technologies that will enhance the senses, including touching, smelling, all senses should be achieved through automation. So this is our ultimate goal and we are moving towards it. So mixed reality combines both AR and VR, where the digital and the real world components interact. Whereas VR is just, it shuts out the real world and exposes us to the artificial world completely. And augmented means some addition. So we are going to add something. So Snapchat lenses and game Pokemon and all, if you have heard of it. Have you heard of Pokemon Go game? Have you heard of that? Anybody? Participants? All participants will be on mute or?
Yes, ma'am.
Okay. They don't have the option of unmuting themselves?
Yes, ma'am. There is a possibility is there.
Okay. So anybody has played or at least seen kids playing Pokemon Go? So that's a very noteworthy augmented reality which reached even small kids. That's when they started realizing the power of AR in gaming. So there we can have this Pokemon components. There are a number of elements, and that elements will be incorporated in the actual real world, and we will be going and catching them. So though it is banned in India because of security reasons, that's where the starting point. And the Snapchat lenses will be covering up a little bit later. So there also some digitally augmented things have been put in the reality world. So these are the main things that we have already discussed: AR, VR, MR and XR. Now before going into devices, if we can answer one important question: why this AR and VR? Aren't we comfortable with our coding devices? We have been doing a lot of work in IT area. We have been into a lot of research. Why are we getting into this AR, VR? Main reason is the cost. See, many of the young people, though they are not into completely IT, they like to get into AR, VR because all the components needed for doing this is available with them. Say, for example, I think yesterday you would have had a session on Google Cardboard. So in that, with just the existing smartphone and a lens and a small magnet and the attachment of a cardboard in a particular dimension, you can place your smartphone inside that and we can get a 3D realization, isn't it? So which means the existing smartphones can be used, or they have the technology required to participate in augmented reality. So that's already available with them. And the second one is, it is not only the smartphones. There are creating apps using smartphones. It has become so easy because lot of open source has been made available for the app developers for doing this apps. So that is another one. And other small components like tablets or computers, smart glasses, sensors, cameras, these are all very commonly available, and also it has become so cheap that all these components can be easily integrated, bought and tested up. So because of all these reasons, the AR VR is picking up because it's a new arena where people can explore a lot. And the data, this kind of data achieved through all these devices, it can be superimposed very easily, simply. It is very conveniently can be superimposed. When something is easy, as well as you need not be a computer whiz kid to do all that. So if you can do that, then why not explore this field? Is what made this AR and VR into a very, what I would say, interesting area to get into it. Okay, so let me go get in. So basically when you are trying to when you are seeing if you have to get into the display devices, you should know what are the characteristics of AR system from a display devices point of view. There are only 3 characteristics that we would be interested. One is the display device should combine real and virtual objects in the real environment. Second one is it should align the real and virtual object with each other. Third one is it should be interactive, and again in real time. So real environment, real time, they should be able to interact. Who should be able to interact? Both the real and virtual objects. So with the 3 main characteristics of a AR system, we have to design the displays. So when we are going to design the displays, I'm sorry, it's going right. So when we are designing I think this also I'll skip. Okay, before going to display, again we will now that we know the characteristics, let us make one simple difference between AR and VR. So I think if you're not on the mute mode, I think you would be able to tell me the main difference between AR and VR. In the case of AR, the systems allows the user to see the real world and virtual objects are superimposed on them. So we will know that, yes, I'm going through this and some extra information comes in the form of a display. So, but in the case of virtual reality, it completely immerses a user inside a synthetic environment, whereas so that the user cannot see the real world around him. So with the characteristics of AR and the main difference between AR and VR, now we are good to go ahead. These are some of the examples. We are good to go with the devices. Now, before we go to the devices as such, you can ask me, ma'am, were there such devices? See, normally, no, anything and everything evolves, right? So we were sort of a monkey some millions of years ago, and due to the nature's evaluation, we have become a superhuman beings, correct? Whether super or not, we have become human beings. So in that case, same way, here we are displays did not jump from heaven just on one day. It was a gradual, improvement of displays. So in earlier, if you say, I can say the primitive AR device is our rear view mirrors, isn't it? So some we are seeing in the front and we are getting some information from background using the rear view mirrors. So if you say rudimentary, if you say elementary, we can say that even a rear view mirror is the first starting point of AR display. Now, but let us not, with the advanced technologies we have, we are not going to talk about that. But later, how it started moving ahead is they wanted some flight training simulator. So the first technically used display for AR is called Link Trainer. So it is the first training simulator display where simulation was given to the flight training, pilots. Instead of flying flight by themselves, this flight simulation was the earliest form of AR displays. Then it came into heads-up display. Many AR, VR book, if you open, you will always end up with a three-letter word, HUD. It is heads-up display or helmet-mounted display. Now, what is this heads-up display? The word itself is very explanatory. Instead of keeping the heads down to see all the monitors, the pilot has to see hundreds of monitors clicking, showing the data or information, but he has to look up also and see where he is going, correct? So there was the display all around him where he can put the heads up and see the important critical values. That's where the initial heads-up devices started. So jet fighters heads-up displays was in functionality right from 1960s. Then it was all in the simulation or defense mode till then. A very big turn came the early 1990s when the video games started using that. That's when the common public was able to realize or they were able to experience the power of AR, VR on a commercial front. So the lot of users, I say, were able to appreciate the AR, AR and VR. But in till 2000, again it was for games, a small amount of gaming technologies, arcades, VR, video games, it was used. And after that, in 2000, another big milestone happened in AR, VR displays. That is when AR toolkits were released. They said it is an open software, libraries are given, and augmented reality can be created. So when you are given the option to the young developers, they started playing around with that. And then it came out of the defense area and it said, okay, let's commercialize it. Let's some of the industries use this. That's when the first thing in 2013, Volkswagen Martha, they were using it for repair assistance. So the service technicians were allowed to see the repair process. The training was given to them using AR/VR tools. Then slowly it came into healthcare. Then I think we have seen a lot of how it is used in education and how it is used in mental health. So all this were the other applications that came after that. And in 2014, a very simple thing. See, till then it was not in the hands of a common man. In 2014, with the shipping of Google Glass, that's the first thing where it was made simplified, cost effective for a user to explore what it is. Then came the headset to fuse AR and VR. So they said augmented reality, augmenting some information to the existing real world. It's well and good. Yes, I'm okay with that. But can we go to the next level? I want to totally get into the virtual world. So from Google Glass, we went to fusing a headset to fuse both AR and VR. That's when Microsoft came up with HoloLens. Then Google Glass. So it's always a competition, right? Healthy competition, which as an end user, we will benefit. And Google released Google Glass for AR, and it was made like a small kiddish component when Microsoft announced Yeah, see here I have a device. I have a display called HoloLens where we can fuse both AR and VR. Now, then what happened? It was not a small group, either a pilot training, front end technicians or service technicians. It is not for that. Unless we make a something for millions of people to use, that technology is not going to pick up. Say, for example, in 1990s or in 2000, when mobiles were used only for limited people. Okay, so it was still, the technology did not grow like that. But in just 20 years, you see, now there are touch phones which are coming even for 3,000 or 2,000. So touch phone, where earlier a phone of a small Nokia, that I mean that earlier Samsung and all, it was so expensive with limited features. Now touch phone has become so cost effective and the technology has blossomed like anything. Why? One and only reason is billions of people have been made to use that way. When Pokemon Go was released in the year 2016, everybody, it was nothing. You just download it and you go around. Your touch phone, smartphone is sufficient for that. You don't need to do anything else. When that scenario came, yes, now everybody sat up and said, oh wow, this is a new technology. Where so it looks more beneficial. So let me not only use it for entertainment or for a small group of people, it should be made useful for a very large crowd. So from there, it started picking up. So in 2018, smart glasses were introduced, and with smart glasses, a lot of it was made. The device was made simpler, smaller, and it was, whenever we say head mounted or you're going to wear a device, what would be the first parameter that will come to your mind? Even for a phone, we would like to have a phone or some head mounted device which is of less weight. So always being bulky means there will be lot of power requirement, and then the battery needs to be strong. So there are so many other issues. So the power emission also will be more. So it goes on. So the smaller, it is simpler, and also it will be more easily acceptable. So in 2018, smart glasses were introduced to get into this AR VR. So this full roadmap, starting from 1900 till 2020, they have seen that how the display has been evolving throughout. And the latest one is the AR framework, which I think in subsequent in next 2 days, after this session in the afternoon itself, you will be having a experimental platform followed by tomorrow's session on euphoria, right? So all this needs to be, it's a very nice area where the human computer interaction has taken a whole lot of a new dimension into computer science as well as information technology. So I think I made a roadmap clear, and what we are going to do is to see the displays. Now when I say displays, so what we are going to do with displays is, before designing a display or before exploring a display, we should also know what are the parameters, that design parameters of AR/VR displays. So there are multiple parameters that when I went through, there are so many parameters that we had to take care. And in that, there could be field of view, box size, resolution, real world or virtual image distortions has to be handled. And of all this, the eye safety and eye relief, peripheral vision, all this has to be considered while designing a display. Now, the main thing here is, I'm going to concentrate only on two design parameters which all the device makers are aiming for: field of view, eye box size. Now, FOV is a very commonly used terminology when you are talking about any display. They will ask, what is the FOV? A new device has come in the market. What is the FOV? What is the eye box size? What is the weight of the component? These are some of the basic parameters that we would, if we are literate about the displays, these are few of the parameters that we would ask. Suppose you are buying a new phone. What would be the basic questions that you will ask? You will ask, being now phone is being used for everything other than talking, we will ask what is the camera pixel size and what is the weight, what is the battery, how long does the battery last. So these are some of the basic questions when we buy a phone. Similarly, when we are looking into AR, VR display, we are going to talk about basic two design principles. One is FOV and another one is eye box size. Now, you can ask me, ma'am, if you are going to hit on one parameter, what about the others? Shouldn't we be improving all of them? Yes, we should be, but our technology has not matured to that level because improving just one parameter is to sacrifice the other one. How? For example, if you are going to increase the FOV, yes, that is not difficult. You can increase it. But what happens? The bulkiness of the devices will increase. And now, and also the eye box will become small, which is not acceptable. The users don't want such a device. Okay. Now let me concentrate on increasing the FOV. I will increase it as well as give a larger eye box in a small display. Yes, that is the most optimum thing. And is it acceptable? Is it technically feasible? No, not it. So, though it is a dream to have a combination of a large FOE, large eye box in a small display, all that is desirable features, but all of them is not acceptable. And when you say I want a large eye box, then there is a more powerful source of light is required. When the light source is increased, then the heat generated will be more. When the heat generated is more, heat dissipation has to be taken care. So there are multiple such factors that gets involved in it. Now you can ask me, ma'am, you are keeping on saying the two words, FOV and large eye box. What are they? Let me quickly tell that because that makes us, that makes the topic, I mean, you can get involved into it. See, FOV is nothing a big term, though, so the term looks big for us. It is nothing but the total angular size of the image visible to both of our eyes. Do we have 360-degree vision, human beings? Without moving our head, can we see 360-degree?
Ma'am, your presentation is not visible, ma'am.
Now?
The screen is not visible, ma'am.
Just a minute. Now?
Yeah, ma'am.
Okay. So, we're talking about the key design factors and we wanted to talk about two important things, field of view, FOV and eye box. So, it is not a Greek and Latin, just a simple technical term given to the angular size of the image visible to a human eye. Now, can we see 360-degree view of without moving our head? It's not possible, right? They say or some birds have more the angular view, but we cannot see. We have limited FO, which is 200 degrees, and that too in which only 120 degrees is binocular overlap. What binocular overlap? Both eyes put together, we can see only 120 degree angle. What things are in that angle? Other than that, we will not be able to see. Also, vertically, you see, vertical field of view is approximately 120 to 130 degree only. Why vertical FOV is needed? It is because all this combined together gives the depth analysis, depth of the object. we are able to analyze the depth of object based on this horizontal and vertical field of view. And for a common eye, it is 200 degrees. Okay. But in all the display devices, as on now, the technology has come to a state where we can give only, make a guess how many we can give. Anybody? We have, yesterday we saw Google Cardboard. We're going to see other components also today. You know what is the maximum field of view current technology is able to achieve? Just 100 to 110 degrees. So which means we are able to give only 50% of our field of view. Technically. So that's one of the challenges we have in finding the next one is eye box. Now, see, for example, there is a very nice, say you have been put in a hill station, say you have been to Shillong or somewhere, or a mountainous area where the natural scenery is so nice. What do? We just open our eyes wide and see, wow, what a scene this is. Correct? So, when we open our eyes wide, what happens? The pupil also get enlarged. So, maximum light goes in. So, we are able to observe the things very to the finest details, right? So, basically, the box volume within which the users can place their pupils. So, if we have to increase the eye box size, then we will be able to see things more clearly and visibility is more sharper. So, that is why I'm planning to consider only this two. I mean, it's not me, it's the IT industry itself. They are concentrating on these two key design parameters. One is FOV and the eye box size. So, getting this itself is a challenge without a bulkier component, bulkier head. Okay. Now, with this thing, now let's go into the display type. Okay, so the display type, there are three display types. One is fully immersive display type, one is optical see-through, and the third one is video see-through. Now, when you say fully immersive, what do we mean by fully immersive? It is actually a display used for virtual reality. So, if you can see this diagram that is sufficient, you will be able to understand. The first one is fully immersive display. So this display, along with the cameras, along with the other things, there is a combined sensors. What are sensors for? It is for tracking, position and orientation. So if they can see my position, where I am standing, which direction I am oriented, then that's when gaming things like Xbox and other games, it needs, even the virtual, it needs to know where we are staying, isn't it? So the extra sensors all will be augmented to this display type. Fully immersive display type, they will completely block the user's view of outside world. That is one type of display. The second one is called optical display. Now, what is this in optical see-through? So here, the user views the reality through all components, such as holographic waveguides, and then we will see what it is shortly in the next few slides. Okay. So this, using holographic waveguides, we are going to overlay graphical objects on the real world. So the example of the displays of the AR devices available is Microsoft's HoloLens, Magic Leap 1, Google Glass. All of them use the optic see-through. And also the third one is video see-through, where there are cameras placed. If you see this, no, you can see a device mounted on the camera. Can you see that? So there is a two cameras are mounted on the display. They capture the image, then image will be joined with the computer generated imaginary and the user will see. So this kind of video see-through technology is also used in display type. Say for example, HTC One VR headset has an inbuilt camera. Okay, that will help us to give us both AR and VR experiences to the user. So basically, the display types is is based on how much we are getting immersed and where is the camera position and what are the devices that are there. In immersive, what did we see? Along the other components, we need sensor integration. In the optic see-through and video see-through, we are not bothered about the position or orientation. So sensors input is not needed, but cameras are needed. So whether camera is one of the optical elements, so the optical elements are used such as holographic waveguides or the cameras. What is being used, whether it is optical see-through or video see-through. And we have seen example, HoloLens uses optical through and HTC VR headset uses video through. Now, you can, this is a very important thing which we will be touching up today. Okay. Friends, my conversation is fine. Do you want me to slow down or go fast?
No, ma'am, fine.
You're comfortable, you are with me, right?
Yes, ma'am.
Okay. So now when we are going to talk about the display devices. So when I say devices, it could be only from the display perspective. Okay. So there are 4 different display devices types. Okay. So it is heads-up, HUDs, heads-up or helmet mounted or head mounted, all comes under HUDs, holographic displays, smart glasses, handheld or smartphone based. So the augmented reality devices, all the devices will come under this 4 categories. You would have seen a couple of them here and there, but I'm going to just explain a little bit of technical input in each one of this, and I will give you an example of a device of under each one of these categories. So that's all we are going to do today. So after that, there are n number of other devices. Those who are interested, take the device and then explore more. Why we should explore more? We from the IT department, we are not going to see it as an end user. We should be interested more in developing applications or developing, using the software development kit for making the AR into the next level. Okay, so that's when we are supposed to know what are all the augmented devices are available, and under this category we will be seeing an example of each one. Now, heads-up device displays. Now, this heads-up display I actually had discussed earlier, isn't it? So this was basically for the pilots when they have to focus on what's happening outside rather than looking at the array of information inside the cockpit. So what they do, they had all the displays surrounding them for mission critical applications. For mission critical applications, when I say it could be flight controllers or weapon system dashboards, for all of that, displays were at the heads-up level where they can just look up. Now that's where this HUD started, and when you see HUDs, basically if you disintegrate heads-up displays or HUDs, henceforth we will use the word HUDs, okay? So it contains mainly 3 components. I need a projector unit, I need a viewing glass, and I need a symbol generator based on the input. Here symbol generator is nothing but our system. So these are the main 3 components used in any heads-up displays, and it can be more sophisticated. Now, this heads-up HUDs, later the next logical step is move the heads-up displays from the windshield of a flight controller into a helmet so that we can wear it and then do. But basically, the helmet mounted displays and headset devices, you both use the same technology. So that's why they all have integrated everything into HUDs. And now it is called the head mounted displays. So this is where we have to spend a little bit more time. Now, this word head mounted display itself is very self-explanatory. Something is mounted on our head and they cannot just be put on the head, right? They are not hair clips. So we need a kind of a helmet to hold it. So head mounted display or a head mounted display, both we are going to call it as HMD, is a display device for giving us the AR, VR, for using the AR or VR technology. Okay. Now, what do they have? They basically have, it's not rocket science, guys. It is just one. I can say that it is worn on the head and it has a display optic. And the display optic can be one or two. So it can be just for either one eye, as in Google Glass, or it can be on both the eyes, or in some other devices that we are going to see. Okay. So it is just a display optic in mounted on a helmet. So that's all is HMD. It looks very simple, right? So the basic component, the basic display device. Yesterday, I think that session is done, right? Google Cardboard. Hello.
Yes, ma'am.
Okay. So what did we do yesterday in Google Cardboard? What were the components that we had? A cardboard box with a particular dimension, a magnet, then smartphone, and some velcros to hold it together. So some basic things, correct? So the basic thing to put it on our head and use the smartphone for getting the AR experience. So that was the first rudimentary or elementary product from Google Cardboard. So that's the basic thing. But what are the other HMDs available which is of more widely used? If you see this, no, you can, it's worth going through HTC Vive, Microsoft's HoloLens, Oculus VR. Apart from Sony PlayStation, I think Sony PlayStation, many people would have seen in, though we have bought it or not, if we go to any malls where they play, I mean, Sony PlayStation shops, if we go, no, they give this experience. So, this is some of the head-mounted devices that we have available. Now, what we are going to do is, Google Cardboard, I think I'm not going to discuss much, but this one is, let's see. So, though I have given less credit to Google Cardboard, I said it just play kit kind, but it is a wonderful starting point where Google was able to give the augmented reality to the end users at a very cheap price of even less than 250 rupees. But it did not do much of it. There are other headset gears, Samsung gear, as well as Oculus Rift VR HMDs priced at 14 and 22K. So, of course, the more it costs, there has a lot of facilities that has been brought inside that, isn't it? So, these are some of the head-mounted gears which is available as of now. Now, I'm not going to spend much, but before I go to the next serious topic, I would like to tell something similar to Google Cardboard. Snapchat lenses. This I saw one of my niece playing. So suddenly he had sent me a picture, my own picture, with a kind of a different hairstyle and bigger ears. I was asking what happened, how did you do this? So what is it? He has just augmented to the original image some other digital images. He had put a bigger ears for me and he said, there is a rabbit. So I made you into a rabbit. So that has been done by the Snapchat lenses. So they are actually, it gives the AR experiences and it transforms the world around you. Now, what are these? They are nothing but filters that superimpose 2D and 3D artwork onto the user's face or surroundings. It's like a small using in chats. Say, how does it work? It's just, we'll consider this as one of the simplest display. What do we do? It is a application, AR application developed. And how does it work? It doesn't need anything special. It just needs filters used for image processing. And what are the things we do? We detect the face, facial landmarks, and then do a little bit of image processing. And using, I think we know support vector machine as well as the HOG, right? They are all the techniques used for identifying the face. If you have studied or if you have invested more on face detection or the boundary detection, or to, I mean, there are projects where students used to do, right? To find out the face, whether it is happy or sad. How do we find out? So if there is a triangular point that we can make between the eyebrows and the nose, and then we can even find out the face of the person and recognize. So those 3 vital points are sufficient. So, and there are n number of face detection algorithms. So the simplest is histogram of HOGs and SVMs is used for detecting the face. Once the face is detected, then you find the landmarks which is nothing but the coordinates of eyes, nose or mouth, whatever it is, and then add extra component to this. Correct? So we found where to keep that ears and where to put a tongue out. So it is nothing but you have identified a face, you have found the contour of the face, and we have added a digital component to it. Isn't it an AR system, guys? What did we do? Did we buy expensive software or expensive sensor or nothing? It is just an app that has been developed using the existing image processing thing. So this is Snapchat is one of the wonderful example where the experience of AR has been made. Though, so, but this is again a small kid-like stuff where they were able to realize the power of AR. But when it comes to Oculus Rift, this is one thing where you have to, this slide, guys, I'm not going to explore more into how it is working and all that. But one thing I want to tell about this is how this area is generating revenue like anything. Oculus Rift was first started in the year 2012, where it was introduced in a game as a gaming unit. When we are giving it as a gaming unit, what happens? They were trying to see how they are able to see the virtual reality, how they are able to hold the ball, throw the ball, something like that, right? But within a couple of years, that company got sold for 2.4 million, Oculus Rift, and then they went to development of DK2, the same inventors. Okay. So Palmer, they went into they sold the basic thing and then they went ahead and they started revamp the DK2, development kit 2 model, and they are continuing to work. Why I am talking about this particular point while we are technically discussing about the display types is the opportunities in this AR VR displays. So smaller, what starts, anything that is gaining popularity among the people gets sold immediately, right? So even with the small thing, We have so many such small startups which gets absorbed by the bigger company and they use it, isn't it? So similarly, Oculus Rift is one such example. And the next one is HTC Vive. So in this, what is the specialty of this head-mounted devices? You can move around a room scale virtual environment. Slowly, we are moving from AR to VR. So, what is the main difference between AR and VR? From a technical perspective, see, from application point, yes, I totally forget about my reality. I go into virtual world. That's common man definition. But from our perspective, when I say that we are going into virtual world, the orientation as well as my position coordinates have to be sensed every second. Whenever there is a movement or every second or a regular intervals, it has to be tracked. The position, physical location needs to be tracked, and then that is used to interact with the immersive fantasy worlds. Okay, so there are games where you can play without anything. You can play the tennis with a player, isn't it? So there you feel as if you are in a tennis court and you are hitting ball. Yes, you are just moving your hand this side and that side. But wearing head-mounted device, the components will be augmented. So though you are just moving your hand, will be a bat inside. You can just imagine as a smaller example. Okay, so the bat and ball will be precisely calculated when it should go and come back. So that virtual reality will be embedded into this. So HTC Vive is another attempt where they try to bring in the virtual reality in this. Okay, so this Vive PRE. So this headset, it includes controllers, base stations, and also, so when I say base stations will be cutting the sensors input, processing, and then giving the for augmenting with the digital information. Fine, guys. So till now, where are we? Quick recap of what we have been doing. I know it is towards this time and you have a pretty long session from 9. So let's just do a quick recap. So we started with what is here, we discussed MR, XR, then we saw main characteristics of AR, then we moved on to displays, and then for going into displays, we listed out the different parameters, and then we said FOV and eye box size are the critical parameters that we would be concentrating. But if you concentrate on both of that, performance, improvising on both of the parameters, then we would end up with a bulkier thing. So there is a no win-win situation there in improving the parameters. So after all that, we concluded that yes, these are the things to be taken care while designing a display. Then we moved into the display types. So one is fully immersive, next one is optical see-through, and another one is video see-through. And then we saw what is what. Then we moved into augmented reality devices, where we have 4 different devices. One is head-mounted, holographic, smart glasses, and what was the last one? Anything? Handheld smart base. Remember that 4-line tree kind of diagram we had shown?
Handheld.
Yes. Thank you. Okay, so we saw that reality AR devices types are the 4. Then we started looking into HUDs. We saw how HUDs are right. Started with heads-up displays and ended up with helmet-mounted devices. And this helmet-mounted displays, basic one, the initial primitive one was Google Cardboard, but still we will give a credit to that because of the experience it gave the end users using just cardboard box and available smartphones. Then we moved into HMDs, and then we saw a number of HMDs are there. You're able to see my display?
No, ma'am.
Somehow it goes off. Just a second. So in HMDs available, we saw a number of HMDs, right? In that, he said that HTC Vive, Microsoft HoloLens, Oculus, and Sony PlayStation, they are all worthy. And in that, we saw what is Oculus Rift, just to say the financial impact these devices are creating. And HTC Vive, we just prove the way the AR and VR has been brought into a single head-mounted device. Till now, we were talking only about AR. This HTC, along with the base station, it was able to find our location, position, orientation, and it was collected through sensors to the base station for computation, and augmented with other data to give us the virtual world. Now, this I don't want to discuss more because of time constraint. I had a very nice comparison of all the head-mounted devices. But all this, whatever we have compared, no, when we compare, there's only one thing that is different, guys. We have taken the comparison of Oculus Rift, HTC Vive, and another PSVR. There is only three parameters that distinguishes between the HMDs. Can anybody tell what it is? Apart from price, of course. Price varies. Their Oculus is around $1,500 and HTC is $1,800. That's the headset. The basic thing is the field of view. Unfortunately, all the HMDs that we have been looking into, HTC Vive or Oculus Rift and others, they all have 100 to 110 of field view, and the headset weight is around 1 pound or around 500 to 600 grams. And another important thing is resolution. Resolution we are able to maintain to some acceptable range, but this field of view is still a big concern when you compare all the HMDs. I have done a comparison of all the things. So still, when you compare each one, I found that FOV is the main case where if at all anybody wants to take up research into this, you can work in improving the FOV. Any IT faculty, or if you have very good students working under you, you can assign this kind of a device or display building where the FOV is increased at least 250 degrees. Those there is one product, Samsung says that we are going to increase. They also ended up with 96 degrees only, not even more than that. Okay, so this is the, I had put this slide again just to refresh. So augmented reality devices, we have seen something about head-mounted devices. We compared from the financial point of view and also technical point of view and also on the design point of view. Okay. Now, what is the next holographic displays? There isn't much to discuss here, guys. Why? Because this holographic views, it is more into the research still. They do not, this holographic displays, they do not require users to wear any gear to view them, is one of the greatest advantages. But they have to, the display is using light diffraction. It generates a 3D forms of object in the real space. So that's holograms, isn't it? So using that displays, maybe we will be able to get into the AR VR realization. So many of the Star Wars series or the Minority Report, or there are a lot of serials which are there which uses this holographic displays, but still a lot of research needs to go into this because many of the holographic properties are still under research and it continues to remain as a science fiction. But always we know, right? Science fictions end up making people think more and ending up something with new products. The last display is smart glasses. When I say smart glasses, the immediate thing that should come into your mind is Google Glass. Now, what is the smart glasses? It is a wearable device. Yes, I understand when you say eyeglasses, it is a wearable computing device in the form of eyeglasses, but it is computerized. When I say it is, and it also is called HMD, but it is OHMD. Why? There is an initial O there because it is optical head-mounted display, which is wearable and it has the capability of reflecting the projected images as well as user can see through it. Okay. So these are the now before getting into smart glasses, I want to revisit the technologies which we already have seen. One is optical see-through, the other one is the video see-through. Remember when we were talking about the technologies, fully immersive, optical see-through and video see-through. We saw 3 technologies, isn't it? In that, now let's concentrate on optical and video see-through because those are the technologies used in smart glasses. And even in that, we are not, video see-through is not much used because of a lot of limitations in using this video see-through. Why? Video see-through needs a camera, it has to capture the images, then it has to combine with the things. So whenever there are a lot of activities, it makes the system bulkier. And whenever the system is bulkier, the real time has to be compromised because processing has to take place. It might take few more nanoseconds. So that real time interaction there might be a latency involved in it. Okay? So that is when more than video see-through, why VR headset uses video see-through, but glasses, the other smart glasses still stick on to optical see-through. Okay, it is simple and it is also using less of technology. Fine, guys. Now, I will touch upon a very small thing which you need to know, waveguides. See, we are going to use optical see-through. We have to, here the user will be able to see the world directly, as if I am wearing a specs. I should be able to see the world directly through that glass, first condition. Second condition, I have to add a virtual content. How do I add a virtual content? By having an additional light on top of the light coming from the real world. So I'm looking, so the light from you gets in my eyes and it gets reflected into retina and I'm able to recognize, yes, our Professor Lata Jyoti is standing in front of me. But apart from that, I want to know some more details. So I would like to know what is her address, what is she, other academic achievements of her. There are many things that I might like to know about her. If there are some small tags that come around her telling that her research area is this, she has achieved this, her students have done kind of notable work. Some information if it has to come to it. How do I get it done? I will add a additional light on top of the light coming from the source and add both of that and do that. So this is done using waveguides. How do I do that? Basically, it's an additive operation, isn't it? So when you are doing an additive operation, there is one lacuna that you must be aware of it. Coordinators, I'll try to finish it in 5 to 10 minutes. Okay.
Okay, ma'am. Okay.
No problem, right?
Yes, ma'am.
Okay. So in this, no, whenever there is an additional additive operation of two light waves, then you cannot show black color. Now, when I say you cannot show black color, what happens in this optical see-through displays? You can never show shadows. So this is one of the serious, what should I say, restrictions available with today's optics, and that's why it's called passive optics, because I can never add shadows to it, as I cannot add a black or a black virtual content. I cannot add to the light because of the additive nature. Now, so when I am saying this optical see-through, it uses only one thing called waveguides. The principle used is waveguides. I know this is looks like a diagram which we saw in 10th or 12th in our physics book, right? So it's something similar to that. If you look into it, waveguides is nothing but a physical structure in optics that guides a light wave to a user. See that there is a projector and the light wave comes, it reaches the eyes in both the cases, correct? So the top one uses the projector, light comes, and here what happens in the first waveguide, it goes through a device. There is a total internal reflection. The light wave gets reflected multiple times before reaching the eyes, and from the real world, light wave comes in the total internal reflected light that also gets merged and reaches the eyes. So either you can have a waveguide principle where this mixing of both external light and the augment light source is added to give us the information to the eyes. So this is the basic principle of waveguides. Waveguides is the physical structure in optics guiding the light wave. Now the light wave is not just a light wave, it is a mix of actual light wave and the augmented light. I think that makes things clear, right? So when I say that this is the principle used, what are the components that are needed for this? We need a projector that inserts an image one location of the waveguide. So it at the top it is putting its own image. Then what happens? Due to total internal reflection, it bounces inside the waveguide, like how it happens in a fiber optic cable. Then it exits at the other location. It is called outcoupling. It is first one is incoupling. This is outcoupling where it reaches the eyes. Now, when it is getting into the eyes at the outcoupling end, they are mixing our real light. So it is very simple. It is very easy to do, but there is a lot of quality issues in this. The quality of the image looks sort of distorted. So in the list of parameters in design principle, you would have seen in the last but 2 or 3 that there is a what is it? Quality or image distortion problem. So the image gets slightly distorted, but it's one of the simplest way of using it. That is why it is, whenever the technology is simple, we can end up with having lot of small components based on small display devices. So the smart glasses, because of this simplest waveguide principle used in optical see-through, we have n number of smart glasses. So you can just go through. Sony has given all n number of companies have come out with their own smart glasses, where Google Glass is one of the noteworthy, because we are very much comfortable with the word Google. When you just go through itself, in your mind, it would have registered. Google Glass would have got registered, and Sony's viewer would have got registered, isn't it? So let us just go quickly about Google Glass. This is how it looks. Doesn't it look like a simple glass, guys? It is lightweighted. With a small attachment in the front. Other than that, it looks like a perfect normal glass. Now, What is speciality of this Google Glass? It is wearable and it is a voice and motion controlled Android devices. And it resembles a pair, looks like an eyeglass only, but it displays information directly in the user's field of vision. Now, so what does it do basically when I say that it displays information in the user's field of vision between the objects, say between the processor and between my eyesight, there is another layer of information gets displayed. So that offers an augmented reality experience by using visual, audio, location-based inputs to provide the relevant information. Say for example, if you are entering an airport, you can automatically receive the flight status information. So there are some very nice things that you can see. If you have time now, I would request you to go through this Google Glass completely, and it's very simple, as well as you can make things, you can make a Google Glass. If you have the IoT components and the small components, we can do this. But though it is anything looking simple, needs a lot of performance improvement. But actually Google Glass was later even discontinued. The first version of Google Glass was discontinued because of its poor quality, but still we discuss it because I am not going to get into more of how the Google it is working, but I can just say that it gives the experience of AR. Fine. So I have taken this as a case study of explaining, but I think this is sufficient. Just exposure to the unit will make you more inquisitive to know more about it. Okay. Just when you go through the features of this Google Glass, which is working on the optic display property, it has the ability to take photos, videos, and share exactly what the user is seeing through the Google Hangouts is there. So using that you can send, and also you can get a reminder to complete certain chores or tasks with an added visual aspect. Say for example, you are looking at a particular object, then immediately it says, oh, this has to be given for a service. See how nice if that information is coming. Normally our mind reflects, right? There is a non-working tube light blinking. When you look at it, when you enter your room and look at it, not even in the daytime, in the night, when you switch on and it blinks, you say, oh, I should have changed the bulb. But when you look at the object itself, if there is a information coming to in front of your visual saying this needs to be changed. See how good it would be. It's a very simple thing to do, but still it makes it efficient, and it supports both voice and video calls. So in video calls, the person who is wearing can show the other person exactly what they are looking at instead of talking face to face. And also, the more than all this all I will call it a cosmetic application. The most important thing that would be useful is ability to answer emails and text messages using voice dictation. You and me, we don't need, we can just type it, but they are physically challenged people who cannot, or they can be people with some kind of stroke affected people who are unable to move their hands. They are physically challenged in one way or other. For them, this kind of devices would be of very much useful. See, if you see from entertainment perspective, till now we were having different AR, VR displays, everything. The general opinion of any user would be, what did ma'am say? She said about some entertainment, some application here and there. No. Basically, all this would make more sense if such devices are used for a social cause. And a social cause, main social cause, if you think of, to help a human being who is physically challenged. He could be visually impaired or hearing impaired, or it could be autism, or it could be a stroke affected person. So all these augmented devices are getting into healthcare. I think there is a separate session, isn't it? When is it? It's over. Yesterday, I think you would have had, right? AR in healthcare and mental health issues, sorry. So all this is where this devices gives a social impact on what we are doing. So with this, I think I am going to skip all this. So I had actually yesterday after doing the slides, no, I thought that I need 3 hours to complete. I was able to gather so much information, but I will skip all that and I will tell you the final one word about it. So all these applications, I think. This I want everybody to have a look at it. See, AR, VR, as I told you, it should not be used only as a entertainment or a augmented thing. No, let's not talk only about it. So we should also know the risks involved in having this. So virtual reality or artificial reality health risks. First is anxiety. See, now if you are seeing through your common eyes, what happens? Nothing. We are able to see for 24 hours also a day. Doesn't matter. Our eye get a little bit of strained. But if you have been asked to wear something and something gets superimposed, what happens? Are we not stressing our brain? Brain knows to collect information from one sense organ, eyes, and it processes and it gives us a sensation of viewing things. But now I'm adding something to it and I'm trying to put more stress on the brain. So this creates a kind of a anxiety because our brain is not used to doing these things, isn't it? That is one kind of a stress to the brain. The other one is, say for example, there is a war scene and you are seeing that war scene in a virtual reality mode. What happens? It's as if you are inside that war and you are seeing things. So it also creates a lot of mental stress. So it makes you feel as if that feeling of terror and anxiety and fear sets into us, even though it is not a real thing, isn't it? So virtually you are inducing something which is creating anxiety and stress, apart from creating physical stress to your brain. So this kind of AR, VR, health risks are also to be experimented. I mean, it's also under discussion and research. The next one is nauseous. As I told, whenever you have, I think most of us would have had migraine, headache or headache. Even small headache when you get you wouldn't like any kind of input to your senses. Senses in the sense, you will close your eyes, you will say, don't make noise. I already have a headache. By saying that, what do? We are shutting the input to the ears. Then we close the eyes. So the senses, the viewing senses prevented. Then we don't talk. We sit quietly so that no other senses in our body is working. Why are we doing that in a headache? Because we are giving rest to the brain, isn't it? If you don't do that, what happens? It creates a nauseous. You feel like dizziness, vomiting sensation. Why? The senses are being overused. Simple. You play a video game for 3 hours. After that, you see how you feel. Your head will be kind of dizzy, isn't it? So such kind of health risks are there because you are interfering with the senses which brain knows to handle. You are tampering with that. So that is another big healthcare risk which we should be thinking about it, apart from eye strain. Eye does not know to handle multiple inputs. It knows it has its own way of getting things. It knows the way how to identify color, how to identify depth, how to identify the distance of the object. Every damn thing our eye knows to do. It picks up all that cues, processes it and says, yes, the book is on the table which is 5 feet away from me. It is of this much size. It has this much of weight. So many things I'm able to grasp from just looking at an object. So which means eye sense is a very, very critical sense which should not be strained. But what do we do? All the head mounted devices, what do we do? We say, I very clearly said, add a display, add a light source, give a projector on top of it. Done. It is not so easy because you are tampering with the natural way the body senses works, apart from the radiation exposure. We all, I think all of us will agree that the little sparrows that which we used to enjoy has almost disappeared because of the cell phone towers, isn't it? The more cell phone tower comes, the small sparrows community is getting, it is coming into a minority population now, isn't it? So the radiation effect of many of the devices, we don't know, but we are not worried. We are tuned to that comfort zone. To be very honestly speaking, we are tuned to all that comfort zone where we feel that it's okay, let's see what happens. And that radiation is going to have a lot of impact in the later world. So any technology, it should not be used just like that because it gives an entertainment or something. It should serve a purpose. So the AR, VR displays also is a very good improvisation of the technology, I agree. And it is to be used for a social, with a social sense and not for just entertainment or for other needs. So if you are able to do that, then I think this AR, VR is one of the boom to our current IT world, where lot of other fields can explore the benefits of that, be it education or medical field where surgeries are being done, or even autism kids can be trained. So all this is possible with AR, VR, provided it has been used properly. So these are some of the things that I would like to share on the AR, VR displays. And I really thank each one of you for your patient hearing. And that's where I conclude with my talk on displays in AR, VR.
Thank you, ma'am.
Thank you.
Thank you, ma'am. Participants, if you have any queries, kindly post it in chat box.
And you can note down my mail ID also. It is rjanandi@hotmail.com, or even Professor Lata Jyoti can share it with you. If any of you or your students are working in AR, VR, you can please get back to me with anything which I can be of use. And I think Ms. Ponni, it is 1 o'clock and I don't see any input in the chat box. I don't expect also.
Okay, ma'am. Thank you, ma'am, for describing several AR VR components to render the animation and explanation towards the implementation point of view, and some real-time applications also. And I feel it will be productive and beneficial for the faculties. Once again, we will thank you for your treasured contribution, ma'am.
Thank you.
Thank you, ma'am.
Thank you so much, ma'am.
Yeah.
Participants, you can join